distance between the incenter and the circumcenter of a triangle. The incenter of a triangle is the circle in center of the circle inscribed in the triangle. While as you can see, I is the incenter, while C is the center of the circle that is circumscribing the triangle. So C is for the bigger circle, while I is for the small circle. So the distance we're looking for from I to C, so let's call it D. So let's extend E. Now let's draw a line that passes through E and I and to the circumference of the circle, and also extend GH to meet a point on the circumference. So let's do it. So I've extended this. So let's call this A, this point, and call here B. So there is a formula or theorem that EI as EI times IB is equal to AI times IG. It's called power of a point, or called intersecting chord theorem. So EI times IB is the same as AI times IG. So, and again, you can easily see that AI will be, C is the center of the big circle. So also, you see that CG and CA are the same, but they gave me D. So meaning the remaining, which is AI, is R minus D. Why IG? So since here is CG is R and IC is D, so we have R plus D. Okay, let's draw a line that passes through FI and also that passes through FB. So let's draw two extra auxiliary lines. Okay, as you can see, we'll have the lines. So, and looking at this, remember this is the incenter, making I, as you can see, okay, let me level here. Let's call here C. Okay, we'll have C. Let's call here D. So we can see that ED is an angle bisector, yes, because it passes through the incenter. So the angle here, if we call here theta 1, here is also theta 1. Yes. So, and again, F, even if you extend this down here, so FI is also an angle since it passes through the incenter. So if we call here theta 2, here is also theta 2. Okay, so by a stereo angle theorem, we'll see that this angle will be theta 1 plus theta 2. Okay, so here is theta 1 plus theta 2. Here is theta 2. And again, from what we call inscribe angle theorem, so look at this arc. We see that if you extend it, that's why we added this, we have an angle here. So we have an inscribed angle, and again the same arc, there's an angle here. So by inscribe angle theorem, this is also theta 1. So we are still correct. We see that FB and IB are equal because triangle IFB is an isosceles triangle because they have the same base angle. Here is theta 1 plus theta 2. This is also theta 1 plus theta 2. So making the length FB and IB to be equal. So I will replace IB with FB. Why this one will turn to difference of 2 squared? We know that the expansion is this. And two auxiliary line, one that passes through C and B to the circumference, and also one that passes through F to the circumference. So let's add it. Okay, so we see, so let's call ABD H. Let's call here H. So what do you have to say? Look at this. Look at this arc. You see that if you extend it to form an angle, and which is the same thing as the angle here. So here is theta 1. Yes, because by inscribe angle theorem, this is theta 1, the angle formed by that same intercepted arc. So they are equal. So here is theta 1. And we know that this is R, and this is also R. That's the radius of the big circle. So what do you see? We'll see that this angle here, that's this, the angle, the total angle here is 90 by Taylor's theorem. Yes, and also since this is the in radius, this angle 90 is always tangent to the side acts as a tangent line. So what am I trying to say? I'm trying to say that triangle, using similar triangle, that triangle E. Okay, here we have H here, so let's call this J. Let's call this J. I didn't know we already have H. So let's call this J. So triangle E H I is similar to triangle J F B by right triangle similarity theorem, because both of them are right triangle. Because this is the diameter of this, JB is the diameter, making angle JFB to be 90. So here is 90, since the radius is always perpendicular to the tangent line. So this is also 90 degrees. From here to here is 90. So that's how we got this the two similar triangles. So what you have to say, we see that EI over, that's EI corresponds of the small triangle corresponds to JB of the big triangle. YHI of the small triangle corresponds to FB of the big triangle. So that's the similarity. So what do you have to say? We'll cross multiply. So we'll see that EI times FB is what? HI times JB. So what do you see? This is equation 1. This is like equation 2. So we see that EI times FB, we can replace this with that. Therefore, we see that, okay, let me use another color. Let me use this. That HI times JB is now equal to r squared minus d squared. That's replacing this, see, with that. So what is hi? Let's look at hi is small letter r times jb. Where's jb? jb is 2 times big letter r squared minus d squared. So here is now 2 r is equal to r squared minus d squared. So making d the subject of formula. Therefore, d is now square root of what? R squared minus 2 r. So now this is the distance between the incenter and the center of a triangle and the circumcenter. So we've gotten this special formula. So wherever you're asked to find the distance between the incenter and the circumcenter, we use this formula. So let's look at this question. We're asked if I is the center of the small circle and C is the center of the large circle, we're asked to find the distance between us. So we've gotten this formula that distance, this now is now square root of what? R squared minus what? 2 r, where r is the in radius, sorry, why big R is the radius, radius of the bigger circle. So we have from here is 3, so 3 squared minus 2 times 1 times 3. So we have this is 9 minus 6 is 3. So the answer is option B. So the formula is very important in solving the distance. So thank you.